Good day, everyone. I am Sharon Brian Rosas. So we are Group 3. I am here with Jose Benjamin Cantos, Jose Cristian Eusebio, Leslie Minjola, Hannah Bea Sandra Nicodemus, Micaela Pantorillo, and Marcangela Trillado. And we are assigned to present the topic drying process and calculations. Next, please. For the list of content, nakahati po siya sa 5 parts. Part 1 po is the introduction, then Part 2, terminologies. Part 3 naman is drying mechanism. Next is methods of drying. And last part po is yung applications of drying processes. Next slide, please. So ano nga ba yung drying process? It is said that drying process is one of the oldest method of preserving food. Tinatawag rin siyang dehydration. Drying basically dehydrates or removes the moisture from the food, and this simple action inhibits the growth of bacteria, mold, and yeast. Moreover, it slows down the enzyme action without deactivating them. These factors ensure that food does not spoil easily, and hence makes drying an effective food preservation technique. So yun nga ginawa basically para mas mapahaba yung lifespan ng mga pagkain at hindi agad masira. Another factor that helps with drying food is humidity. Since involved sa drying yung pagre-remove ng moisture, low humidity will surely help the process. Next slide please. Punta naman tayo sa history of drying processes. Nagsimula siya as early as 12,000 BC. Sun and wind would have naturally dried various food. Such evidences exist and can be seen in Middle East and Oriental cultures. Later cultures left more evidence, and each would have their own methods and materials to preserve their food supplies. Fish, domestic animals, vegetable, fruits, etc. Early Romans were particularly fond of any dried food they could make. Food dehydration was said to be more of a discovery than an invention. Hindi siya agad naisip ng kung sino man. Napansin lang ng early people na accidentally kasi may nahulog na fruit from a tree. And after ma-dried nun sa hot sun, they noticed na edible pa rin ito. Next slide, please. Nung Middle Age naman, nagsimula na baling inventions para ma-explore pa yung process of food dehydration. Yun nga, gumawa sila ng steel houses para pang-dry talaga ng food. Nakalagay dito na residents from Europe's cool or wetter regions began to construct steel houses which were specifically designed to dehydrate food. Then naman sa mid-1800s, mechanized dehydration was the next great thing, and we can thank French investors Mason and Charlotte for it. They devised a method for drying veggies in the air heated to 105 degrees Fahrenheit and then compressing them into vegetable cakes. May nakapag-invent ng device or heating lang yung kailangan para makapag-dry ng vegetable into cakes. Kahit mukhang hindi masarap ganun. Pero sobrang appreciate to ng mga sailors that time kasi considered siya as welcome source of nutrition. Next please. Moving forward, World War II. Due to the need for tiny light rations, combat personnel used them extensively. Aside from dried soups, potatoes, and pudding, very little from the front lines made it home. Then, noong early 1960s naman, dehydrated food made a comeback when back to the land campers and hikers once again discovered its excellent transportability. Bali, mas dumami pa at lumawak pa yung drying process kasabay ng pag-advance ng technology syempre. And up to now, ginagamit pa rin itong method sa iba't ibang klase ng pag-manufacture ng food. Next slide, please.
Okay, so pasok po tayo sa terminologies. Iba po sa terminologies na nagamit sa drying processes is una yung conduction, the process by which heat energy is transmitted through collisions between neighboring atoms or molecules. Conduction occurs more readily in solids and liquids where the particles are closer together than in gases, where particles are further apart. So, ang conduction po yung pagta-transfer pala nung init mula sa isang bagay papunta sa another. So, yun po yung conduction. Convection is this transfer of heat happens when a fluid such as air or water is in motion. Convection is driven by temperature. differences across that fluid. So convection po, nangyayari naman po siya usually sa mga fluids or sa air na gumagalaw. Desiccation, the state of extreme dryness or the process of extreme drying. Evaporation, a type of vaporization that occurs on the surface of a liquid as it changes into the gas phase. Psychrometer, a hygrometer consisting of a wet bulb and a dry bulb thermometer. The difference in the two thermometer readings being used to determine atmospheric humidity. Ito po yung tool na ginagamit para ma-check ang humidity ng isang lugar or ng isang bagay. Steam, water in the gas phase. This may occur due to evaporation or due to boiling, where heat is applied until water reaches the enthalpy of the evaporation. Humidity, the amount of water vapor present in the air. Dehydration, the absence of a sufficient amount of water in your body.
On sa drying mechanism. Drying mechanism is defined as the vaporization and removal of water or other liquids from a solution, suspension, or other solid liquid mixture to form a dry solid. It is a complicated process that involves simultaneous heat and mass transfer accompanied by physico-chemical transformations. Basically, ang meaning lang ng drying mechanism is tatanggalin lang yung water content dun sa product. Before we move on, yung ang itatakil natin sa drying mechanism ay yung stages niya, which is yung constant rate period, falling rate period, and equilibrium. Next slide, please. Stages of the drying mechanism. Definitions nung tatlo. Constant rate period. It is the time when the rate of free water diffusion to the surface surpasses the rate of evaporization and the rate of diffusion of water vapor through the air layer at surface of the solid into the air stream controls this, which is equivalent to evaporation at the surface of a liquid. Falling rate period. As the surface temperature rises, the rate of drying decreases rapidly even if the moisture removal may be much smaller. The falling rate period takes much longer than the constant rate period. Lastly, equilibrium moisture content is the moisture level at which the wood does not gain or lose moisture because it is an equilibrium with the ambient relative humidity and temperature. Before natin siya ma-explain, para mas madali maintindihan, gagamit tayo ng graph para mas madali natin maintindihan yung bawat isa. Next slide. Next slide. So ito yung drying curve. Hindi yata. So drying curve natin, basically yung A to B is absorption of heat by the material and temperature rising. B to C is the temperature is constant. Rate of vaporization is equal to rate of diffusion of the water from the water surface. C to D, rate of drying starts to fall down. And D to E, rate of drying where it completely stops. So, kung anuhin natin yung graph, basically, hindi siya, yung first part, yung A to B is the initial adjustment period. Basically, it's the time corresponding, which this occurs heat transfer from the air to the material. Tapos dito rin nagsa-start yung absorption ng heat doon sa material, kaya tumataas yung temperature. Tsaka at the same time, yung water, nag-move siya sa surface dahil mainit yung pumapasok na hangin. Then yung water, nag-vaporize, nawawala yung water content unti-unti. Then after that, darating siya doon sa B to C, which is yung constant rate period approaching critical moisture content. Kapag nasa constant rate period ka, yung temperature doon basically nagre-remain siya as constant. This happens because the rate of vaporization becomes equal to the rate of diffusion of water from the solid to the surface. So, basta yung water nandun lang siya sa surface niya as at kino-consider siya as wet surface. Yung temperature niya magre-remain lang siyang constant. Then from C to D based sa graph, first falling rate period. Basically kaya lang siyang falling rate period, isabihin mo bumabagal lang yung pagtanggal ng water content kasi doon sa from B to C mataas na yung temperature na binigay niya. Kasi yun yung peak temperature niya. Kaya halos wala na ring water content doon. Then yung parang C to D is parang kumbaga sa ginagawa natin is polishing na lang siya. Kaya unti-unti na bumabagal yung pagtanggal ng water content. Then yung D to A is yung second falling rate period or kapag nag-approach na siya sa letter E, yun na yung equilibrium moisture content na talagang ano na siya, wala na siyang water content.
Next naman, part 4, methods of drying. So, meron tayong natural drying, chemical drying, convective drying, and then other types. So, let me start po sa natural drying. Next slide po. So, under ng natural drying, we have sun drying, a traditional drying method for reducing the moisture content of paddy by spreading the grains under the sun. The solar radiation heats up the grains as well as the surrounding air and thus increases the rate of water evaporating from the grains. So, yung sun drying, yung usual na ginagamit dito sa country natin and madalas itong ginagawa sa mga kalsada, sa roof, or minsan nakahang sa mga tray. So, yung mga example ng products na ginagamitan ng sun drying, yung mga fish, rice, coffee, minsan meat, vegetables, and then usually nga sa mga floor, sa roof, or sa tray. Next naman po. Under din ng natural drying yung shade drying. Shade drying is a kind of method used for products that need their color to be maintained. Therefore, this method is indirectly facing the sun. It is widely used in maintaining the qualities and characteristics that already exist within the bean and extending the longevity of the product. So, yung shade drying naman, kaya siya ginagawa is to slow down the drying phase kasi some products like coffee are taking longer to get to a stable level of water content. So, yung mga example ng products pa under ng shade drying, yung mga beans, coffees, herbs, green and red chilies. Next. Next naman ng method of drying, chemical drying. So, under ng chemical drying, we have spray dryer, the most widely used in chemical, dairy, agrochemical, ceramic, and pharmaceutical industries. It includes atomization of the fluid, mixing of the droplets, drying, and removal and collection of the dry particles. It involves the atomization of a solution, slurry, or emulsion containing one or more components of the desired product into droplets by spraying followed by the rapid evaporation of the sprayed droplets into solid powder by hot air at a certain temperature and pressure. So, the spray dryer nagpo-produce ng dry powder product from liquid by rapidly drying with a hot gas. So, usually ginagamit ito sa mga drug or sa mga pharmaceutical industries nga using lactose or sucrose, and then sa mga flammable products, yung ginagamit doon is usually nitrogen. Next po. Under ulit ng chemical drying, we have rotary drum dryer. Large rotating drums where the material cascades through a stream of hot air. The material is gently dried as it cascades through the hot air flow. The process maintains a safe low oxygen atmosphere inside the dryer loop. The circulation of hot gas reduces the thermal energy consumption. So, the rotary drum dryers naman, it works by tumbling material in a rotating drum in the presence of a drying air. So, madalas ito ginagamit sa mga chemical and mineral industry. Sa food naman, ginagamit yung rotary drum dryer sa pag-dehydrate ng mga waste materials like vegetables nga and some animal feedstuffs. So, ang application din ng rotary drum dryer yung pang-roast ng nuts, sesame seeds, and cocoa beans. Next. So, dito naman yung mga drying agents commonly used for drying solution. So, yung mga example lang nun is itong anhydrous inorganic salt, and then sodium sulfate, and then magnesium sulfate. So, in order to remove the dissolved water, a drying agent is used. Common drying agents are anhydrous inorganic salts that acquire waters of hydration when exposed to moist air or wet solution. For most common drying agents such as sodium sulfate or magnesium sulfate, the crystals form larger clumps when they absorb water. After standing for a short period, the crystals are removed by filtration or decantation, and the solution is then relatively free of water. Next.
So next is for the convective drying. Convective drying is one of the most effective methods for dispersed material dehydration in the chemical, pharmaceutical, mining, and other industrial branches. The direct contact of the drying agent with high temperature potential and dried material enables intensively to remove the surface and absorption-bound moisture. That is why drying is the only method for industries to achieve the required quality of the product. So, yung mga next slides are the types of convective drying. Next po. So, first is the fluidized bed dryer. It is also called as fluid bed dryer. It's a kind of equipment used extensively in the pharmaceutical industries to reduce the moisture content of pharmaceutical powder and granules. The equipment works on a principle of fluidization of the feed materials. In fluidization process, hot air is introduced at higher pressure through a perforated bed of moist solid particulate. The wet solids are lifted from the bottom and suspended in a stream of air. Heat transfer is accomplished by direct contact between the wet solid and hot gases. The vaporized liquid is carried away by the drying gases. Sometimes, to save energy, the exit gas is partially recycled. Next po. Next is the fixed bed dryer. It's a mechanical device or machine that removes the water from wet grains by forcing either ambient air or heated air through the grain belt. In a fixed bed batch dryer, the same quantity of grain is kept stationary in a holding bin until drying is completed. Fixed bed batch dryers produce better grain quality than sand drying, especially in the wet season. They are more affordable than recirculating batch dryers of the same capacity or continuous flow dryers. The most common fixed bed dryers are flatbed dryers, which have a very simple design. Grain is laid out on perforated screen and dried by forcing air from below. The air fan that provides the drying air is usually a simple axial flow fan that is powered by a diesel engine or by an electric motor. A kerosene burner or a biomass stove provides drying heat. The capacity of the dryer varies from 1 to 10 tons. Next po. Next is the solar dryer. It's a more advanced version of conventional sun drying. The product is kept in a transparent container exposed to the sun. The critical difference between SD and sun drying is that the SD requires a solar collector, and the dehydrating product is not exposed to the sun directly, and a control system can be installed on the solar collector. Solar drying has proved to be technically and economically valuable for several crops. It is, however, necessary to develop large-scale dryers that may be used throughout the year for different products to make them attractive to the farmers. Sa indirect solar dryer, the heat of the sun is first captured by the solar collector and the dryer chamber. Tapos, yung ambient air na nagfo-flow dun sa solar collector ay i-heat. Tapos, papasok na siya sa drying chamber. The drying chamber could be a cabinet type or a tunnel where air heated by a solar energy is blown. The air could be moved by natural draft where a chimney is integrated in the system or circulated with a blower in a suction or forced mode. After drying, the air has become humid and is discharged from drying chamber. The solar collector unit is very useful for obtaining air with higher temperature. Next po. Next is the oven drying. It is designed to remove moisture from the oven chamber so to dry the samples as quickly as possible. The drying oven process introduces fresh, dry air to the chamber and expels the warm, moist air simultaneously, allowing to rapidly dry the samples. A drying oven provides high-performance drying and heating. You will notice that drying ovens will be more expensive than a standard laboratory oven, mainly due to the oven having drying capability that is lacking in a laboratory oven. A drying oven requires an airflow system that can extract moistures from the air and depending on your requirements may or not be required. Drying ovens are suitable for up to 300 degrees Celsius. Its purpose is to heat, dry, harden, sterilize materials and parts. In the process of drying materials, fresh air enters through the heating elements and moist air exits. The blower produces temperature uniformity inside the oven by dissipating the hot air. Next po. Heat pump drying. It works as a closed-loop system by heating the air using it to remove moisture from the clothes and then reusing it once the moisture is removed. Rather than releasing warm, humid air through a dryer vent to the exterior of the home as a conventional dryer does, a heat pump dryer sends it through an evaporator to remove the moisture without losing too much heat. Making use of a refrigerant as part of this process means less electricity is used to generate heat. The heat pump dryer consists of a conventional drying chamber with an air circulation system and the usual components of an air conditioning refrigeration system. The drying air is dehumidified by the evaporator and reheated by the condenser of the heat pump. The maximum drying temperature is determined by the condensing temperature of the refrigerant used. Heat pump drying is essentially a low temperature process which can be controlled from negative 20 degrees to 70 degrees by selecting an appropriate refrigerant and regulating the compressor capacity and airflows within the system. Next po. For the last type of convective drying, the endless chain pressure dryer, it consists of 2 or 3 individual tray circuits. When the leaf is fed into the feeding circuit, the spreader feeds the leaf uniformly on the tray. As soon as the leaf completes the run on the top circuit, the tray carrying the leaf are automatically tilted at the end of the circuit and the leaf falls on the mid-circuit where the direction of the tray movement is opposite that of the top circuit. Thus, the leaf is subjected to a gradual high temperature from top to bottom circuit, and drying is completed when the leaf reaches the bottom circuit. Next po.
There are more types of drying methods and dryers. I will present and explain each of it to you. Microwave drying. Microwave drying is a process that basically works in the same way as when we heat food in a microwave oven. This method utilizes microwaves to penetrate moist materials, wherein the microwaves are converted into heat. Moisture from the material evaporates and is carried away from the structure by a fan. If the microwave drying equipment is handled poorly, the microwaves generated during the drying process can be harmful to one's health, especially when exposed to excessive amounts of it. The tissues harmed by microwaves are often below the skin, where there are no sensory cells that could otherwise react to the excessive heat. The health detriment from microwaves that is most well known is cataracts. Next. Vacuum drying. Vacuum drying is a method of drying materials in a low-pressure environment, which reduces the amount of heat required for quick drying. Vacuum dryers are used to dry thermolabile materials at low temperatures and to recover solvents from solid products containing solvents. Steam or hot water is generally channeled through hollow shelves to provide heat. Drying temperatures can be precisely controlled, and the material is kept at the boiling point of the wetting agent for most of the drying cycle. A vacuum dryer is an indirect heat dryer in which heat is delivered to the material as it comes into contact with the heated surface of the dryer, drying it via conduction. Next. Freeze drying. Freeze drying is the removal of ice or other frozen solvents from a material through the process of sublimation, and the removal of bound water molecules through the process of desorption. Sublimation is the direct transition of water from a solid to a gaseous state that does not involve melting. When compared to other methods of drying, freeze-dried foods have a higher quality. The lack of a liquid phase as well as the low temperature of the process contribute to the high quality of the product. Freeze drying keeps the flavor, color, and appearance of the food while reducing thermal damage to heat-sensitive nutrients. The main disadvantage of freeze drying is the high cost of operation and maintenance due to its high energy consumption. The energy required for freeze drying is nearly twice that of conventional air drying. In addition, the cost of freeze drying is 4 to 8 times higher than conventional air drying, and as a result, the process is only economically feasible for high-value food products. Next. Greenhouse drying. Greenhouse drying is a method of removing moisture from the product with the use of solar energy. A greenhouse solar dryer used in this method has the same structure as a regular greenhouse. The use of greenhouse drying also has its advantages. Efficient, since food can be dried more quickly and less will be lost due to spoilage. Healthy products, since drying fresh produce at optimum temperatures enables them to retain more of their nutritional value. Cheap, since it utilizes available solar energy instead of conventional fuels to dry products. Next. Infrared drying. When infrared radiation is used to dry high moisture food products, the energy is absorbed to a small depth before being converted to heat. Infrared rays penetrate the raw material and act on it at a molecular level, allowing for high quality processing and increasing the shelf life of products without the need of preservatives. Infrared drying technique has the following advantages over traditional drying technology: high energy efficiency, short drying time, uniform heating of materials, easy control of material temperature, superior end product quality, and cheap energy costs. Next. Radio frequency drying. Electromagnetic waves are used to thermally prepare foods via radio frequency processing. This process heats from within, eliminating the need for a hot, dry exterior layer. Because the product is heated all the way through, the water in the middle will heat up and rise to the surface. Radio frequency dried items are generally hot and dry on the interior and cooler and wetter on the exterior due to the heat losses at the surface. And that's all for the different methods of drying.
And for the last part of our report are the applications of food drying. Food products. Food drying is method of food preservation in which food is dried or dehydrated or desiccated. Drying inhibits the growth of bacteria, yeasts, and mold through the removal of water. Water is traditionally removed through evaporation, air drying, sun drying, smoking, or wind drying. Although today, electric food dehydrators or freeze drying can be used to speed the drying process and ensure more consistent results. So, yun daw po yung isang application ng food drying is to prolong or preserve the quality of food for future consumption or for storage po. At ang main concept po of food drying is to remove the moisture of food within it. One example po nito is honey. Alam naman po natin na yung honey is hindi po siya nasisira dahil nade-discover po siya sa mga ancient civilizations at until now edible pa rin po yung mga tinago nilang honey. Ang main reason po nun is the low moisture content of honey. Kaya po walang bacteria na dumadami or wala pong bacteria na nag-grow dun sa honey na yun. Kaya po siya na-preserve at pwede pa siyang i-consume until now. So, freeze-dried food, water vapor is released from frozen food during freeze drying. Under these conditions, the food structure is better preserved. To ensure that sublimation occurs, the dryer must be set to appropriate temperatures and pressure. So, tulad nga po ng sinabi ng ating previous reporter, isang method po of food drying is freeze drying po. Which, pinifreeze po muna yung food at dinadala po siya sa vacuum pressure para po mag-sublimate or magkaroon po tayo ng tinatawag na sublimation para po mag-evaporate directly yung water dun sa loob ng ating food. Alam naman po natin na the lower the pressure, the lower po yung ating boiling point. Kaya po kapag finreeze natin yung water at dinala po natin siya sa vacuum, which has a low pressure, mag-evaporate po agad siya, which hindi na po siya dadaan sa liquid phase. From solid phase, magiging gas na po agad yung water content ng food. Nakakatulong po siya sa preservation ng structure ng food dahil nga po hindi na po siya kukulo or hindi na po magta-transform from liquid to gas yung ating moisture dun sa loob ng food. So next slide po. Ito po yung mga examples ng food drying. Hindi pa lang po nag-present yung mga pictures. Pero yung first example po is jerky. Ano po ba tong jerky? In Tagalog po is tapa or yung mga binilad po na meat para po ma-preserve po siya at pwede po siya natin kainin kahit po itago po natin siya na matagal sa ating storage. Ano po yung method na ginagamit para po makapag-produce tayo ng jerky? One of the ways po ay sun drying, oven drying, or with the use of dehydrator, microwave, or smoker. Yun po, pwede po siyang ibilad sa araw or gamitin po natin yung oven para po makapag-produce ng tapa or pwede rin po siyang ilagay sa smoker or yung pinapausukan po para po matuyo yung tubig dun sa loob ng ating meat at maging ano po siya, yung tapa in the end product po. So, isa pa pong food example is dried beans and peas. Ito po yung mga beans po or yung peas na nabibili natin. Hindi naman po yun yung original form or yung original na appearance ng mga beans and peas. Meron po siyang water sa loob at dinalagay lang po natin siya or dinadala lang po natin siya sa ilalim ng araw, sa oven para po magkaroon ng drying at mag-evaporate po yung water moisture content no beans and peas. Ayun po, nagre-reflect na yung mga pictures. Next din naman po ay dried fruits and vegetables. Dito po sa picture is potato chips po siya. At nagdaan po siya sa hot air drying. Pwede rin po vacuum drying, sun drying, and freeze drying. Next naman po dun sa baba is powdered milk. Yung milk po is, alam naman po natin na liquid po siya natin makukuha sa mga cows or sa goats. At nagdadaan po siya sa spray drying. Na-discuss na rin po ito natin previous reporter. At spray drying po is the atomization of a solution, slurry, or emulsion. Basically po, yung liquid form of milk ay ini-spray po siya sa ating evaporator at papadaanin po doon yung hot air at yung end product po niya ay powdered milk. Habang ini-spray po siya, mas mabilis po mag-evaporate yung ating moisture content dahil nga po scattered yung molecules at scattered po yung particles ng ating milk. So, ito po yung way para po makapag-produce ng powdered milk. So, next slide po. So, another example of food drying po ay makikita natin sa pasta. So, yung mga pasta po na nabibili natin na nakapack for spaghetti or yung sa mga cup noodles po, dumadaan po siya sa hot air drying. As can be seen po sa ating picture, makita po doon na nakasampay or nakasabit yung mga pasta. At pinapadaanan po siya ng mainit na hangin para po siya ay matuyo, tumigas at mapak po siya para po mabenta siya sa market. At isa pa pong example is rice. Ito po yung diniscuss din kanina which goes through po sa sun drying or binibilad lang po natin siya sa araw dahil hindi naman po pwedeng balatan po siya agad pagkagapas po dahil kailangan po muna nating patuyuin siya at matanggal po yung moisture content sa loob ng ating palay or rice. So another application po ng drying ay can be applied din po sa non-food products. So the purpose of drying is to make the material easier to handle and process. Drying is required for the manufacture of free-flowing materials in bulk drug manufacturing and large-scale synthetic drug manufacturing. Dry aluminum hydroxide, spray-dried lactose, and so on. So isa pa daw pong purpose of drying ay para naman sa manufacture of free-flowing materials at saka ng mga drugs daw po or pharmaceutical products. Tulad po nung sinabi kanina, hindi naman po, for example po nito is yung ating mga tablets of medicine. Hindi naman po natin pwedeng, actually, pwede po siyang ilagay or i-tablet in liquid form. Madami po na to. Pero mas magiging convenient po at mas magiging mas mabilis at mas madali yung ating manufacturing kung gagawin po siyang powder at ilalagay po dun sa loob ng capsule. So next naman po is drying is especially critical when working with extremely thermolabile compounds that aren't liquid stable. The lyophilization of thermolabile materials extends their shelf life and makes them suitable for storage and transportation. Biological products such as blood plasma, vaccinations, enzymes, microbiological cultures, hormones, and antibiotics, for example, can be dried. So one example din po is nga po mga medical substances na ginagamit po natin at madami pong gumagamit worldwide. So hindi naman po every country can produce na yung mga ganito po. For example, is yung vaccines or yung mga enzymes or yung mga microbiological cultures. Meron po tayong pinagkukunan na to from other countries at tinatransport lang po siya sa atin or sa ibang bansa. So, kailangan po doon, hindi po siya madaling masira or hindi po siya madaling mapanis. So, kailangan po natin siyang i-dry muna para po mas tumagal yung kanyang shelf life at mas malayo po yung maabot po ng mga products na to. For example din po nun is yung blood plasma. Kapag po meron tayong war, yung mga blood plasma po na to ay dala-dala ng ating mga sundalo po. At hindi naman po siya pwede na from directly sa blood, kinuha po sa tao ay dadalhin na siya. Kailangan po muna siyang idaan sa drying para nga po matanggal yung moisture content at mas tumagal po yung shelf life dahil hindi naman po natin alam kung kailan natin gagamitin yung mga gantong products at in case of emergency lang naman po siya magagamit. So next slide po. So it can be used to prevent or eliminate moisture, which causes corrosion and reduces product or medicine stability. For example, to keep crude pharmaceuticals of animal and vegetable origin, synthetic and semi-synthetic drugs from deteriorating or becoming contaminated. So ayun nga po, another example is yung medicinal products. So sa paggawa po ng synthetic at semi-synthetic drugs, kailangan po natin ng drying. So another application for drying is to remove sludge and fecal materials from sanitation processes. So thermal drying is an intermediate sludge and fecal treatment method that involves evaporating the sludge water. It considerably reduces the sludge volume and weight, making it easier to recover. Before being disposed of, sewage sludge is normally dewatered. Even while the watered sludge still includes a large quantity of water, up to 70%, it no longer acts as a liquid and may be treated as a solid substance. The sludge is stabilized by drying, which reduces odors and improves sanitization. The resulting product can be prepared for use in a composting facility by evaporating the water. So kung makikita niyo po sa right side picture, sa top picture po ay isa po siyang pipe na merong sludge sa loob. Or yun po yung mga bara or yung mga materials na naipon po sa loob sa ating mga pipes, sa ating mga sanitary pipes po. At hindi naman po siya agad-agad kinukuha dahil nga po mahirap po siyang kunin in liquid, in marami po siyang liquid content. So ang kadalasan pong ginagawa ay dinadaan po siya sa thermal drying para mag-evaporate po yung, hindi naman po lahat ng water content, which ang in-evaporate lang po ay yung mostly of the water content po na to. Para po siya ay ma-consider as solid at mas madali po siyang ma-handle. So after po nun, kukunin na po siya ng ating mga sanitary facilitators po. Tapos yun po yung ginagawa or pagkatapos po siyang i-dry, pwede rin pong gamitin yung mga sludge na yun para po bilang fertilizer po sa ating mga composting facility. So yun po yung isa pang application of drying. So yun na po yung last part ng aming report. Next slide. So thank you for listening. If you have any queries po or suggestions, you can contact us at our email po. Thank you po.